trying to determine the scale factor that's used to dilate a figure. Might be one where we're given both the original and the final figure. So we can see here that we have all of the A, B, C, and D. These are all of our original points. So let's go ahead and write down our coordinates for all of those original points. Then over here with the primes, I can see these are all of my new points after the dilation occurred. So I want to be going back through and writing down those points as well. So I have all of my points. Now, I need to determine what the scale factor was that was used to dilate this object. How can we figure this out? Andrea? By dividing it. So she's saying that our scale factor tells us that whatever our new figure is divided by our old figure would tell us how much we multiplied by. So this is really thinking about an inverse operation here. The operation that happened was each of these numbers was multiplied to get the next one. So we know something was multiplied to get this. So the inverse of that would be to divide. So I can divide my new point, which was -2, by my old point, which was -1. That tells me the scale factor was 2. Now we can go through and we can quickly double check all of this. Times 2, 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 times 2. And make sure that everything fits. Well, over here, 2 times 2 gave me the 4. -4 times the 2 gave me -8. This seems to be working. 2 times 2 gives me the 4. 2 times 2 gives me the 4. -1 times 2 gave me -2, and so on and so on. So all of these points fit for us, and that tells us that that's exactly what we needed to do to figure out what the scale factor was here. Now, I also want to write that scale factor as a percentage of the original, which means that I have to take this quote-unquote decimal and change it to a percent. How am I going to do that? What is 2 as a decimal? William? What? And how'd you do that? Yeah, so we start with the decimal here, and we move it 2 times to the right to give ourselves 200%. All right, over here we have a slightly different problem. They didn't give us the figure already drawn, but we need to find how much this was dilated. So what did we say we could do to find out how much something was dilated? Yes? Yeah, the new divided by the old. And so I can take any point that I want to. So I might come over here and choose this one that went from a 6 to a 9. My new is the 9, my 6 was the old. And that tells me I got 3/2, which is 1.5. Now, one thing that we should be thinking about here is when we get done and we figure out what our scale factor is, we have a scale factor of 1.5. What does that tell us should be happening to the figure? Yeah, it should be getting bigger. So let's double check and make sure that our points are indeed getting bigger. So we went from 5 to 7.5. That got bigger. 3 to 4.5. That got bigger. -4 to -6. Got quote-unquote bigger. 6 to 9 got bigger. Okay, so this makes sense that our scale factor is 1.5. And that's definitely one good thing that we want to check. I also want to know what the scale factor would be as a percentage of the original. Jefferson. 150%. We can take that decimal, move it 2 times, and that would leave us with 150%. Alright, looking over here, we have another one that is drawn on a grid, so I can copy down all of my original points. All of my original points are the ones without the primes. So those points, their coordinates are -2, 4, -2, -2, and 4, 4. My new points are these ones that with the primes, and it looks like the B prime lost its prime somewhere. And C prime here. A prime is -1, 2. And -2 or -1, -1, and C prime is 2, 2. So we need to find the scale factor for this one. Now, did our shape get bigger or smaller? So what should I expect to be true about my scale factor? What should be true about my scale factor if my shape is going to get smaller? Jorge. It's going to be less than 1. And this is really a good check because a lot of times people will look at this and they'll be like, oh, the difference is a multiplication of 2. But as we look forward, if you multiply -2 by 2, you're going to get -4. So this obviously is not a multiplication of 2. So we can find it by, again, taking the new point divided by the old point to figure out what the scale factor is. I can take any one that I want. This is my new is -1, my old is -2. If I do that division, I'm going to get 0.5. What is this as a percentage of the original figure? Henry? 50%. Move the decimal 2 times. Right, and the last type of problem when we might try to find the scale, they're going to give us the lengths of the sides, but we know the lengths of the sides follow the scale factor just like everything else. This tells us figure ABC, so that must be the original, is dilated to be A prime, B prime, C prime. So this is our new figure. It tells us that AB is 5 centimeters, so AB, that must be the old. And A prime, B prime, that must be the new. What is the scale factor used for this? So I want to figure this out, same way as we do before. One thing I'm going to ask myself while I'm writing it down is, did this figure get bigger or smaller? Did this figure get bigger or smaller? Smaller. Okay, so we should definitely be making sure that we have this set up right such that we get a number less than 1. So our new is 4, our old was 5, so this is a scale factor of 0.8. That makes sense since our figure got smaller. And what would this be as a percentage of the original? Jalen. 80%. Alright, and down here, I want you to go ahead and answer this question all on your own.